Hey, attends, how's it going? Do you know what? We have almost finished the register already, which is amazing. Only missing a couple of people. I am missing Nick, surprise, surprise, Toby, surprise, surprise, and Ben, surprise, surprise. Tong, can you go and find out where Ben is? Oh, Ben is on his way. Amazing. I like it. Yeah, so just 3 people, and then we can crack on. So, guys, I'm going through the reactions homework. Ooh, it's a really good point, this, guys. So, question on the chat. Has anyone not managed to finish it? You had half a lesson. You had about 20 minutes of the last lesson to try and get his way through it as best you can. Did everyone manage to finish it? Yeah, I'll just check with you guys will be able to input your scores once we've gone through it. But that's all I'm doing today, folks. No homework tonight. Yeah, none. All I'm doing is going through. Yeah, finished. Almost finished. Yup, Ben. Oh, hello, Ben. Hello, Ben's in the house. So just missing Toby and Nick now. I'll put them as missing. And then when they turn up, I will mark them as in. Fine. Finish. Harry's almost. Moses almost. Ben finished. Amazing. Guys, I know it was a long homework. I know, and I'm sorry about that. The other class had a big go at me. Made me really upset. Really upset me. Jai finish. Finny. I like it. Almost on Andy's front. I like it. Okay, folks, so I'm going to start going through it. You can mark it as we go. It is a big hitter in terms of marks-wise. So I'm just going to quickly find the sheet, and we can have a look. I'm just trying. Finish. Well done, Tong. It's in my starred ones. Where do I find it? Year 10 homework data sheet. Yay. Yeah, look at this. Acid base is out of 38. Woo! It's a big one. It's a big one. Right. I am, by the way, Anna, I am missing the last 4 homeworks from you. Would you be able to put those in by the end of today? That would be amazing. Harris, I'm missing 2 homeworks for you. Can you put those in? Andy, I'm missing 2. Ruby, I'm missing a couple, just a couple of blank spots. Might be worth just filling them in. Okay. Very confused about what is going on. Very strange that. Some people are putting them in as fractions. Don't need to put them in as fractions, guys. Just put them in as the number. Yeah, don't do a fraction. Otherwise, it looks like you've got 1 out of 4, 1 out of 6. Yeah. I don't quite know what's going on there. Anyway, right, guys, let's crack on. Okay, let's go. Let's go. Share screen. Let's share screen. We go. We're in. Right. So here's your homework, guys. This is what I set you guys up with. Our next lesson is on solubility. That's tomorrow. But this is just, I just want to go through this with you. I see the value in us going through all these things and me adding in those additional bits of detail that'll make us better chemists. So the first one, so out of 5, let's go draw. Okay. Right. Metal plus acid gives me salt and hydrogen. Check it if you've got it. Doesn't matter about the capitals. Won't matter. Salt, that's terrible handwriting today. I'll fix that in a minute. Salt and hydrogen. Metal oxide plus acid. Salt plus water. Like it. Metal hydroxide. Salt and water. Different one. Metal carbonate plus acid. Salt, water, and carbon dioxide. Yeah, it's good. Next. Now, guys, you're not going to like this. French for water, that's correct. Toby, well done. So glad that I'm teaching you French at the same time. Water. Yeah, French. Guys, you're not going to like ammonia. I'm hoping that you guys looked this up, because the answer to this one is salt. And that is it. I know. Let me explain why. So this is out of 5. 1, 2, 3, 4, 5. Let me explain why ammonia is different. Ammonia is a very special substance, and we've got to know her. Yeah, ammonia. NH3. So the first thing I need all of you guys to realize is that it is a base. Yeah. Just to tell you, by the way, it is actually a weak base. Yeah. It's got a pH of about 11. It's got a pH of about 11. So it's a weak base, it is partially ionized in water. Do you hear what I nearly said? Not fully. You're not allowed to do it. I've picked up a habit from seeing you guys write it down and me having to explain it. It's partially ionized in water. So ammonia is special. The reason being, I'm just going to get rid of all this now. Although, can I just point out that that information is actually really, really good chemistry. It's a weak base, about pH 11. You have to know the pH of ammonia, by the way, in year 13 for A2 chemistry. But here's the weird bit. When you add an acid to ammonia, something very strange happens, which is the H plus, rather than the H plus from the acid binding with an oxygen or taking electrons from a metal, what actually happens is it combines to form ammonium. It combines to the nitrogen. So you actually get ammonium chloride. Just to show you this as a picture, to show you the proton transfer, here's actually what happens. The ammonia, I'm trying to do dot and cross here. Yeah, Lewis dot and cross. Here's ammonia, and I'm drawing this for a reason. Yeah, so ammonia is NH3. By the way, on the chat, please, what kind of bonding is taking place in ammonia, please, Toby? So here's ammonia. I've asked Toby for its bonding type. What bonding is it? Next, we're going to react it with hydrochloric acid. Covalent. Thank you, Ruby. Thank you, Toby. Great job. It is covalent. If you want to write the word simple, you can. Here's hydrochloric acid. Now, what happens is the proton just simply swaps over. Yeah? I'm tempted to see if I can actually draw this. Yeah? What's going to happen is the hydrogen gets picked up by the lone pair of electrons on the nitrogen. So it just literally sees the other pair of electrons, which causes it to become NH3, and the chlorine becomes chloride, having its electrons left behind. It's kind of nice, that. So it's still proton transfer. Still proton transfer, but rather an unusual one, because you're not forming water or hydrogen. It's rather unusual. This is much, much harder, folks. You have to know this one. So number 1, on the chat, can someone name it, please? Number 2, bonding. On the chat, please. Go. Let's see if you guys get that one. That one's much more challenging. One is going to be first on the chat for this. Well done. Ruby's on fire today. Look at that. Ammonium chloride, ammonium chloride, ammonium chloride. That's amazing. Well done. Ashley just put D. Oh, D because you put ammonium chlorides. That's amazing. What type of bonding is it? Kieran, well done. It is ammonium chloride, and it's a very unusual one. It breaks a rule at GCSE. This is ionic, and this is very unusual because there's no metal. Yeah, this is very, very odd. Ruby, I totally get it. It's okay. That's why I know it's a nightmare. Yeah, it breaks a rule. That's so annoying. I know it's annoying, Isabel, but the problem is there's always exceptions to the rule. And this is one of them. That's why it's nice to bring it up. Yeah, it's ionic. So it's a giant ionic lattice. You know, if you're gonna run Susan Boyle. Oh my goodness, I nearly said something else. Nothing else though. Next. Okay, so now we've been through that one. Oh, do you want another one? That's so not frustrating. I know. Do you want another one though? Let's do another one. Let's do the bonding, of course, is covalent for that one as well. Covalent. Simple. I like saying the word simple at GCSE. I do like that. So if we do another reaction, such as ammonia plus sulfuric acid, impress me, year 10. What salt am I going to make? Can I have the name and the formula? 1 mark for each one of you. Yeah. What's the name? What is the bonding type? What's the bonding? And what's the formulae? This one's the top one's the formulae. Well done, Shanley. It is ammonium. So she's given me the name, which is great. Ammonium sulfate. See why the homeworks make you a better chemist? Tong smashes it out the park. Well done, guys. Bonding is indeed ionic, and it is NH4, but in a bracket. That's hard, that. Can I just point out that is A star level 9 GCSE. That there is a love 9 at GCSE. It's also a grade D at A level. Yeah, well done. Ruby, don't forget, be careful with it, Ruby. So I've got to balance the equation. Remember, so just to show you what's going on here from a reaction perspective, I'll make the pen a bit thicker. Here's what's happening. Here's sulfuric acid. Sulfuric acid's rather a funky looking guy. There we go. There's sulfuric acid. And here's now what happens. 2 ammonias come along with their electrons. That's the pair of electrons on the nitrogen. And it steals the H. That pair of electrons rolls back. By the way, this is called a mechanism. This comes straight out of AS chemistry. Yeah, picks up the H and those electrons roll back. So what we end up with is 2 NH4 plus ions. Yeah, and they're between the SO4 2- sign. You know, of course, it's a giant ionic lattice in reality, but it's just really, really nice to see it smart. Smart? What's smart? So you have to just remember on our formula that we've got NH4, which is the plus ion always goes first in the formula, and we have 2 of them, SO4. It's actually the cross and down trick, of course. Yeah, so if I do the cross and down trick, I've got a 1 plus, I need 1 sulfate, but I need 2 ammoniums. Yeah. You kind of get the picture. Anyway, cool to see that. Proton transfer, you actually don't even cover that mechanism at AS. I don't even think you even covered it at A2, actually, although I do teach it. Right, now that we've looked at that, let's go on to this table. Right, complete the table, show the name of the salt. Right, guys, I'm not going to write the name. It's going to take me too long. Yeah, I'll say the name and then write the formula. So nitric acid, so this is sodium nitrate. Yeah, sodium nitrate, NaNO3. The reason why it's NaNO3 is because it's +1 for sodium, -1 for nitrate. Right, hydrochloric acid and sodium carbonate. So that's going to be sodium chloride. And then sulfuric acid, that's going to be sodium sulfate. Nice and easy. And the sulfate is spelt with an F. I'm just going to shrink my pen. It's a bit fat. There we go. Next, magnesium and nitric acid. I'm going to form magnesium nitrate. Different formula because the nitrate ion is 1-, but the Mg is 2+. Then we get magnesium chloride, MgCl2, because it's Cl- and Mg2+. And then we get magnesium sulfate, which is just MgSO4, because Mg is 2+ and sulfate is 2-. Next, potassium oxide. So that's going to form potassium nitrate, which is KNO3, +1 for potassium, -1 for nitrate. Then we're going to get potassium chloride, because potassium +1, chloride 1-, and then K2SO4 for potassium sulfate, because it's K1+ SO4 2-. You need 2 pluses for every 2-. So K2SO4. Now this one, of course, is a problem. Guys, the internet is full of great resources, but sometimes it's got bad chemistry. That should have had the Roman numeral 2 in it. So if it's copper 2 hydroxide, I'm going to form copper 2 nitrate. Copper 2 nitrate is Cu brackets NO3 brackets 2, copper 2 nitrate, and then copper 2 chloride, and then copper 2 sulfate, CuSO4. If I write sulfate instead of sulfate in a test, Ben, that's a really good question. So sulfate is spelled correctly with an F, but it was an ancient misspelling in English with a PH because of phosphorus and phosphate, but it's actually with an F. They will give you it in the exam still, but they're busy trying to work it out. So it's best to try and switch to the F if you can. Yeah, it's worth, I've had to make the effort as well, by the way. Yeah, I don't know why I wrote one set of words in there. Don't know why. Sodium sulfate, SO4. Next, ammonium nitrate, NH4NO3. And then ammonium chloride, NH4Cl. And then ammonium sulfate, NH4 brackets 2 SO4 with there. There we go. So cool stuff. I'm just going to do a couple of quick questions on the chat. Okay, I'm going to circle some of these. I accidentally wrote the formula for all of them instead of the name. That is absolutely fine, Isabel. I don't mind. I've done the same thing too. That's absolutely fine. Do remember, though, in the exam, if they ask you for a name and you give a formula, you will lose the mark in reality. But I don't, in fact, can I just say, Isabel, can I ask you a quick question on the chat? Did you get every formula correct? Because if you did, that's amazing. How many marks is that question? 1, 2, 3, it's 15, isn't it? 15 marks for that question. 5 for that one, 15 for that one, except 2 ammonia questions. Okay, do you know what? Good to fix them though, definitely. Keep working at it. You're doing great. Wow, bravo. Yeah, well, I know, right? It's great. So really quick bit of old testing. Right. Are you ready? I wonder if anyone can guess what I'm about to do. I wrote both, but got the formula wrong on 2. Would I lose 2 marks? No, in reality, Ruby, the mark was for the name. If you've made a mistake on the formula, just make the correction and that's fine with me. You can still have the mark, absolutely. Okay. Right, I'm going to do everybody on the chat. Let's see how many people are still in the room. Okay, so I'm going to ask Ruby for the first one. Ruby, I am going to flame test sodium nitrate. What color will I see? Next, I'm going to ask Con. Haven't seen you in a while, Con, on the chat. Con, I am going to flame test potassium chloride. What color am I going to see? Ruby, you star. Well done. It is indeed yellow. Sun yellow sodium. Well done, Ruby. Con, potassium chloride, please. What flame color am I going to see? I'm now going to ask Isabel. What color flame test am I going to see if I flame test copper 2 nitrate? Well done, Con, with his lilac. He even gave the absolute correct color there. It's not used pink. Not used purple. He's been brilliant and given me a solid lilac. Well done. I now asked Isabel for copper 2 nitrate on the flame test. I'm now also going to ask, is there any others? No. Okay. Oh, yes, I am. Sorry. Oh, Kieran, I'm going to ask you, how do I test for the sulphate ion, please? Isabel's just said brown. Brown flame test. Isabel, you've gone completely mad. The test for iron 3+ with sodium hydroxide gives a brown precipitate. That is definitely wrong. Blue, there's another color that goes with it. EdXL in their infinite wisdom. Blue. Boo blue. I don't know what boo blue is, but it sounds cool no matter what it is. It's blue green, but I think they'd give you it for blue, by the way. They damn well should do, by the way, because it's blue. Yeah, it's actually blue-green on the flame test. Oh, I don't like that. I prefer blue, by the way, Isabel. I always quoted blue in my exams. Yeah, blue-green, that's the one. Is that the one with barium chloride? I think. Oh, no. Kieran, learn your tests, please. But I need more than just barium chloride. How do I test for a sulphate ion? There's 2 chemicals, Kieran. You're better than this. Come on. What goes before the barium chloride, as you've put it? Barium chloride. Is that the effervescence one? No, it's not, Kieran. Kieran, come on, dude. Learn your tests, please. I will bully you into doing it, you know. Can I ask Ruby? Ruby, can I have the test for a sulphate ion? Can you make Kieran look bad? Kieran has embarrassed himself. And no, you can't add sulfuric acid. You added not sulfur. Oh my goodness. Oh my goodness. You added not sulfuric acid. Is that a joke? Which acid do you add, please? Such a disaster. Test for the sulphate ion. Hydrochloric acid followed by barium chloride. That was a disaster, Kieran. I'm not impressed, young man. White precipitate. Thank you, Ruby. Ruby's on it, you see. Next. Okay. I'm going to ask Tong, because Tong's just chirped in. I love it. I love it when people chirp in. Tong, how do I test for the chloride ion, please? Give me the two substances and the observation, please. How do I test for it? Never goes away, you know. Never goes away. I guess is, oh my goodness. Ruby, don't say that. You meant to make Kieran look bad. Can't have any credit. It is a white precipitate for barium chloride and hydrochloric acid with a sulfate ion. Add nitric acid followed by silver nitrate. Superb, Tong. What observation am I going to see for a chloride ion? Jesus, look at that. She is on it. We add nitric acid followed by silver nitrate. And what do I see, Tong? Come on, Tong. Come on. What am I going to see? A white PPT. Outstanding. Great job. Outstanding. Okay, Tong, you can now seriously impress me. How could I confirm that it's the white precipitate and not the cream? Oh, this isn't even on the Edexcel specification. This is beyond Edexcel GCSE. It is on AQA GCSE, but this is actually Edexcel A level. How do I prove it's a white PPT? If you can't remember, Tong, don't worry. There aren't any other tests for me to do here. Add ammonia, then the precipitate redissolves or dissolves. Well, Tong, I am so impressed with you, young lady. Can you give me the word that has to go before ammonia? Guys, I want all of you to be, can everyone give Tong a round of applause? Because that is outstanding chemistry knowledge. The ammonia has to have it. Well done, Tong. It is dilute. Well done. I bet she looked. Ha, 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 ha. Ben, she hasn't got time. Are you messing? Clapping 100%? Honestly, like, Tong, I am so made up with you. Honestly, that's such, look at that. I'm even, oh my God, I've just found something amazing. Check out that. That's what you should be doing right now, Tong. That is the best thing I've seen in ages. Mr. Duncan just dabbed. I wrote it in my book. I know you did, Tong, because it's amazing. Is that a dab? Yeah, it is. Yeah, it is. Next. Okay. Right. The big one. I am so impressed. Toby dabbed too. Boom. Both Tobys in the room dabbed. Yes. Booyakasha. Bra, bra, bra. Oh my God, I just went too far. I'm so sorry. I lost my mark. I'm sorry. I don't know what happened. It was Toby's fault. It's all Toby's fault. Okay, right. Let's finish off some word equations and then convert to symbol. So what I'm going to do is I'm going to do the word and the symbol on the same line. You can tick it when you've got it. Oh no, that's brilliant. So iron plus hydrochloric acid. Now, just to let you know, right, this question's actually a bit tricky, this one. I actually gave you guys a rule. Toby's like, what? I gave you guys a rule, which is if you don't get told a Roman numeral, generally go for 2+. Exactly. I've got the same name as Toby. Yeah, absolutely. Thanks, Sean. Yeah, he's blaming himself. Sorry, I've lost my mind. But with iron, most common is a 3+. If you put a 2, I don't mind. In the word equation, this will form iron. Now, if you put a 2, I'm totally fine with that. Yeah, but you must have a Roman numeral. Yeah, in your answer to gain this mark, you must have a Roman numeral, either a 2 or a 3. I'm going to ask Shanley. Shanley, what is the color of iron 3 chloride in solution, please? I'm now going to also ask Wen, haven't seen you in a while, or Nick. Yeah, Wen or Nick, what is the color of iron 2 in solution? Metal plus acid gives me salt and hydrogen. Now I've gone for iron 3 here because that's the most common ion. Iron tends to be iron 3 rather than iron 2. I know, it's just, you just have to learn that one as well. When green, well done, young lady, outstanding. Iron 2 plus is, so iron 2 plus is green in solution. Well done. Yeah, iron 2 plus. Iron 2 is green. And iron 3? Iron 3 plus? In solution, Shan. Shan, you're wrong. Yeah, it's yellow in solution, brown as a precipitate. Yellow or brown. They'll actually probably give you brown. Yeah. Yellow is a solution, brown precipitate with sodium hydroxide. Actually, all I actually need you to have is brown, to be fair. I don't actually need the yellow in solution. Not that it matters. Right, let's write the balanced equation. Right. So, Fe plus HCl. Now, if you've done like me, iron 3 plus, it would be that and hydrogen. If you guys did iron 2 plus, it would be that. It will change your balancing. So whichever one it is, just check your balance is correct. So the iron is 1 and 1. Hydrogen is 1 and 2. Chlorines, I'm going to do the chlorines first. It's going to be a common denominator. That's going to be awkward as in it. So if I do that, I'm going to get 1.5 on the hydrogen. Double everybody. Oh, that's awkward. Yeah, double everyone. 2, 6, 2, and 3. If you did mine. If you did the other one, yeah, if you did iron 2 plus, it's actually a lot easier, isn't it? FeCl2, because you no need to do the common denominator. You just do that, I believe. And you're done. Look at that. It's easier. Wait, Mr. I thought you said only do 2 to 9. Oh! Did it? Does it only say do 2 to 9? It does. You're right. Ignore me. You're at RTFQ. Thank you. Who did that? Kieran. Thanks, Kieran. Totally correct. Only says do 2 to 9. So you only need to have the 1 mark for the word equation. 1 mark for that word equation, folks. Yeah, don't need the symbol. If you did it, great. Next, hydrochloric acid plus copper carbonate is going to form copper. Let's try again. Copper, Roman numeral. Now you go back to your normal 2 rule. Copper 2 chloride. And, it was a carbonate plus water and carbon dioxide. There's the word. 1 mark for the word, folks. 1 mark for the word equation. The symbol equation becomes copper, HCl, was hydrochloric acid, wasn't it? Hydrochloric acid plus CuCO3, copper 2 carbonate, going to copper 2 chloride plus CO2 plus H2O. And I think, nope, I think it's now balanced. We need the 2. Don't forget your 2. Yep, so that one there, I'm just going to change my pencil to red. 1 mark for the word, 1 mark for the symbol. Next, laptop's taking its time. Right, iron 2 hydroxide, metal hydroxide plus acid, salt, and water. So I'm going to get to iron 2. There's the Roman numeral. Iron, Roman numeral 2, sulfate with an F. Yeah, and water. Done. Right now, formula. This is much harder. You realize the level jump it gets to when you're doing switching to formulae. Iron 2 hydroxide plus sulfuric acid goes to just iron 2 sulfate, which is just that, and water. And you'll probably find that that now balances. Done. I like it. Mr. Duncan, I didn't see part C. Tong and Ben, I didn't see part C too. Okay. What I'd probably say, it's tricky that. Pause the video, do them now. Yeah. Mr. Duncan, in an exam, if they don't give you the Roman numeral for iron, do we assume 2 or 3? 3 for iron, Shanley. Iron stands out as an oddity. Yeah, it's a 3. Other people of interest? Scandium is always a 4 plus. Oh, hang on, is it? Hang on a minute. Scandium? No, scandium's always a 3 plus. Always. Titanium's usually always +4, although there is a rare +2. Yeah, don't worry about the rest. The rest of them just assume 2+ if it doesn't say, but it'll usually say sham. They have to say. Anyone who has forgotten to do the symbol, yeah, pause the video now, do them, and then just continue watching it back and add your results to the screen when you're ready. Yeah, that's fine. Next, right, nitric acid plus calcium. So I'm going to form calcium, no Roman numeral needed because it's in group 2. Calcium nitrate. I've only got calcium nitrate, acid, metal oxide plus acid, salt and water. Yeah, formulae, change to symbol equation. Yeah, change to symbol equation. So I've got nitric acid plus calcium oxide. Was it oxide? It was, wasn't it? Yeah. Plus calcium oxide goes to tricky calcium nitrate. Calcium's the 2 plus, nitrate 1 minus, and water. Balance the equations, and I think I'm done. Yep, I'm done. Nice. 1 mark for that one. I promise you guys, these will make you better chemists. Yeah, the more I give you, the more of these I give you, the better. Next. Oh, this is a lovely one. It's ammonia. You only get salt. Ammonium sulfate. We're done. Ammonium sulfate with an F. Give equations. Sulfuric acid, H2SO4, plus ammonia, NH3, goes to ammonium bracket 2SO4, and I need a 2 there, and I'm done. 1 mark for that one and that one. It's annoying this. It's just not as responsive as I wish it was at times. Okay, they flipped it on you. Oh, aren't they clever? So you're forming carbon dioxide and water. It was a carbonate. The sulfate tells us it was sulfuric acid, and it was zinc carbonate. So the words are zinc carbonate plus sulfuric acid. Sulfuric acid goes to zinc, sulfate, water, and CO2. Now I need to do the equation. Zinc is always a +2, by the way. Yeah, zinc carbonate plus sulfuric acid goes to form zinc sulfate plus CO2 plus H2O, and I think you will find it's balanced. Winner. Hard that. God, it's really hard. Yeah, 2 marks for that one. Next. Only 4 to go. We're doing well. Magnesium, nitrate, and hydrogen. So the acid was nitric acid, and because you got hydrogen, it must have been a metal. So this is magnesium, metal. You don't need to write the word metal. Magnesium plus nitric acid will form magnesium, nitrate, and hydrogen equation. Mg plus HNO3 goes to form Mg, tricky one, because it's an Mg2 plus and NO3 1 minus. Yeah, plus hydrogen gas, balance it, and it balances. Tick, tick, 2 there. Next, ammonium nitrate. Oh, that's nice. Ammonia and nitric acid, always lovely. Ammonia plus nitric acid will form ammonium nitrate, and then it ends. Nothing out of the product. Equation NH3 plus HNO3 goes to NH4NO3, which makes total sense. It's all balanced. The reason being is because ammonium is +1 and nitrate is 1 minus. Yeah, 2 marks again. It's just a little bit unresponsive. There we go. Next. Ooh, that's clever. So we know the acid. That was hydrochloric. Hydrochloric acid plus potassium oxide goes potassium chloride and water. Yeah, it's rather clever that you can build them like this, isn't it? Right, so HCl plus, was that potassium oxide? Yeah, K2O goes to KCl plus water. Balance the equation. 2 potassiums, 2 chlorines, I think that now adds up. Yeah, there you go. Tricky one, that. Tricky one. 1 for the word, 1 for the symbol. I think we're on the last equation, folks. Calcium hydroxide. Oh, okay. That's mean. It's citric acid. Citric acid to make a citrate. Yeah. And metal hydroxide plus acid, salt, and water. Oh, you can't do the equation for the last one, hence 1 to 9. So 1 mark for that one. Okay, total marks for section for the last one. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 for the last section. Total is out of 38, I do believe. Oh. Hello? Lazada? Are you at the front door? At the lobby. Brilliant. On our way. Thank you. Yeah, we're coming down now. Sorry about that, folks. I just did a call. Lazada's calling me. They're obviously delivering something. No idea what they're delivering, actually. We're at 38. I hope not. Take your... Okay. There you go, guys. It's out of 38. Whenever you're ready, you can input your data. I can end the lesson here today. We're not going to go any further. It's nice that other data has been put in. Well done. That's great. I'll just... there we go. I'll bring you guys back. Woo. Oh, we're back. Oh, it's finished. I know it was hard, folks. Yeah, that was hard chemistry, that. But do you know what? What a great worksheet. You will be a better chemist as a result of that. I'd love to give you like 5 more of them. Just keep giving them to you. Just go, go, go. You'd be amazing chemist. If you can do that, you can do all the other bits. It gets easier after that. Right, guys, I'm going to love you and leave you. Have a great rest of your day, Year 10s. As always, thank you for being such great students and being so great on the chat. You guys have been awesome, as always. Can we also give another round of applause for Tong? Definitely student of the lesson there. I'm dabbing again. Boom! There you go. I actually dabbed. I can't believe I did that. Another round of applause for Tong, because I was so impressed. Yeah, good job. You did great today. Guys, you all did wonderfully. Well done. Thank you. I'll see you all tomorrow. See you later, guys.